December 2024. A satellite camera snaps photos over a hidden Chinese airbase. What it finds shocks military experts worldwide. Two strange aircraft sit on the runway. No one outside China knew they existed. One is called the J-36. Its shape looks like nothing America has ever built. And it just changed everything we thought we knew about air warfare. The J-36 employs a tailless flying wing configuration with 3 engines. This trijet arrangement marks a departure from conventional twin-engine designs seen in most modern fighters. The aircraft's broad and flat profile aims to minimize radar cross-section from multiple angles. Defense analysts examining satellite photos note the absence of vertical stabilizers, a feature that typically creates significant radar returns. Instead, the J-36 relies on its wing shape and control surfaces for directional stability. Recent imagery from January 2025 reveals substantial modifications to the prototype. The aircraft now features new thrust-vectoring exhaust nozzles, a technology that allows pilots to direct engine thrust for enhanced maneuverability. These nozzles replace the earlier standard configuration observed in December 2024 photos. The update occurred within weeks of the prototype's first public appearance, suggesting an active development program rather than a static technology demonstrator. The air intake design has also undergone revision. Earlier photos showed one intake configuration, while January 2025 imagery displays modified intakes positioned differently on the airframe. These changes indicate ongoing refinement of the aircraft's propulsion system integration. Thrust vectoring combined with the flying wing design potentially enables the J-36 to execute maneuvers beyond the capability of conventional fighters. The aircraft's internal weapons bay appears substantial in size. Open-source intelligence analysts estimate the bay could accommodate multiple long-range air-to-air missiles or precision-guided munitions. A large payload capacity extends the aircraft's operational flexibility, allowing it to serve multiple mission profiles without external weapons that compromise stealth characteristics. The weapons bay's dimensions suggest compatibility with China's PL-15 and PL-17 air-to-air missiles, as well as precision strike munitions for ground attack missions. Pentagon assessments acknowledge China's progress in 6th-generation fighter development. A recent Department of Defense report states that China is advancing multiple programs simultaneously, including what appears to be both a heavy tactical fighter and a separate lighter design. The J-36 falls into the heavy tactical category, with dimensions suggesting a wingspan exceeding 60 feet based on comparative analysis with known aircraft parked nearby. The program's timeline defies earlier Western predictions. Just 3 years ago, defense analysts projected China would require another decade to field a 6th-generation prototype. The appearance of not one but 2 distinct designs in 2024 demonstrates accelerated development capabilities. Chinese aerospace manufacturers have compressed development cycles that previously took Western nations significantly longer to complete. This acceleration reflects China's substantial investment in aerospace research and manufacturing infrastructure and talent development over the past 2 decades. Stealth characteristics extend beyond radar signature reduction. The J-36's design incorporates features aimed at reducing infrared detectability. The exhaust system's configuration visible in recent imagery suggests heat signature management through mixing of engine exhaust with ambient air. This approach complicates infrared missile tracking and detection by airborne sensors. The aircraft's smooth and continuous surface reduces thermal hotspots that would otherwise create detectable signatures. The blended wing body design provides additional advantages beyond stealth. This configuration generates lift across the entire airframe rather than relying primarily on traditional wings. The result is improved fuel efficiency and extended range compared to conventional fighter designs. Range becomes particularly important in Pacific theater operations, where distances between bases and potential conflict zones span thousands of miles. The aircraft's potential role extends beyond traditional air superiority missions. Defense observers note the J-36's size and payload capacity make it suitable as a command platform for coordinating unmanned combat aerial vehicles. This manned-unmanned teaming concept, where a crewed fighter directs multiple drones in combat, represents a key element of 6th-generation warfare doctrine. The J-36 could theoretically control a formation of loyal wingman drones, multiplying its combat effectiveness without exposing additional pilots to risk. Comparisons with American programs highlight different design priorities. The United States Air Force's Next Generation Air Dominance program, potentially designated F-47, emphasizes different capabilities. American concepts reportedly prioritize extreme range and sensor integration over the flying wing configuration China selected. The J-36's trijet design provides redundancy and potentially greater thrust, while American designs focus on efficiency and sustainability over the aircraft's operational lifespan. China's secretive test base, where both prototypes appeared, sits in a remote region far from major population centers. The facility includes multiple runways and extensive ground support infrastructure. Satellite tracking shows increased activity at the base throughout 2024, with new hangar construction and runway extensions completed in the months before the prototype's appearance. The base's location provides isolation necessary for testing classified aircraft away from foreign surveillance, though satellite imagery still captures development activities. Engine technology remains a critical question. The J-36 requires 3 high-performance engines capable of supercruise and thrust vectoring. Chinese engine development has historically lagged behind Western capabilities, but recent domestic designs show substantial improvement. The WS-15 engine developed for the J-20 stealth fighter demonstrates China's advancing turbofan technology. Whether the J-36 uses this engine or a newer variant remains unconfirmed. Engine reliability and performance will ultimately determine whether the aircraft meets its operational requirements. The aircraft's avionics and sensor suite cannot be determined from external imagery alone. Sixth-generation fighters typically integrate advanced radar systems and electronic warfare capabilities and distributed aperture sensors, providing 360-degree situational awareness. China's investment in artificial intelligence and sensor fusion technology suggests the J-36 incorporates these systems, though specific capabilities remain classified. Modern combat aircraft depend as much on sensors and software as on aerodynamic performance and weapons capacity. Material science advances enable the J-36's construction. Composite materials and advanced manufacturing techniques allow creation of complex curved surfaces required for the flying wing design. These materials must withstand extreme temperatures, blow and structural loads, and environmental conditions while maintaining radar-absorbent properties. China's progress in materials engineering supports the rapid development of advanced airframes that would have been impossible to manufacture 2 decades ago. Production timelines and deployment plans have not been disclosed by Chinese military authorities. Western 6th-generation programs face delays and budget constraints, potentially creating a window where China achieves initial operational capability first. The rapid progression from concept to flying prototype indicates China's commitment to fielding the aircraft within this decade. However, moving from prototype to production-ready aircraft requires solving numerous engineering challenges and establishing manufacturing processes for complex components. The second prototype observed at the test facility represents a different design approach. This aircraft features a more conventional configuration with canards and a twin-engine layout. The simultaneous development of 2 distinct 6th-generation designs allows China to evaluate different technological pathways before committing to full-scale production. This parallel development strategy reduces risk by preventing reliance on a single design concept that might encounter unforeseen problems. Networking capabilities will define 6th-generation fighter effectiveness. The J-36 must communicate with other aircraft and ground stations and satellites and naval vessels to achieve its full potential. China's development of military communication networks and data link systems supports this integration. The aircraft likely incorporates secure and high-bandwidth communication systems resistant to jamming and interception. The J-36's emergence signals a shift in global air power dynamics. China now demonstrates technological capabilities previously exclusive to the United States. The aircraft's design choices and rapid development timeline challenge assumptions about Chinese aerospace engineering and military aviation strategy. Whether the J-36 achieves its apparent potential depends on factors beyond aerodynamic design, including engine performance and avionics integration and pilot training and operational doctrine development.